one axle's brand new, one axle's brand new and the other axle's not, now you've got a change of angle in the vehicle, and you may have to correct that with ride heights and stuff like that. So there's a lot of things that start to come into play with this, including what if it's an active suspension? That suspension's probably got to be in a certain ride height condition, whether it's the high or the low or the normal, before you would set this up. Steve K, I bet it would certainly see false obstacles. Yeah, if your thrust is off, you're pointing your camera or you're pointing your radar in the wrong direction, and that cone is going to pick up things it shouldn't be. Hunter says less than 1 degree. And I remember watching another webinar not long ago, and they were saying like 1 degree off at the vehicle was like 9 to 12 feet off at 100 yards. So again, we need to remember that the way that cone projects out from whether it's a camera or a radar, the farther it goes, the bigger the cone gets. So little amounts at the car result in big amounts at distance. And if you're, on a fairly open freeway, you're picking up cars that are 100 yards off. And if you're picking up the car that's in your lane, that's great. If you're picking up the car that's in the lane next to you, that's not so good. So those things come into play. Richard Donia just finished a 1,200-mile highway trip with a 2018 Corolla with active cruise, emergency braking, and lane keep assist. If I took my hands off the steering wheel, waited 10 seconds, then it lit up and said, hold steering wheel. It also asks if I want to take a rest on long trips. Many features are customizable by TechStream or audio unit. Yeah, and I think within reason, there's a lot of things are, and some of them right through the instrument cluster itself when it comes to sensitivities, where you can make it more sensitive, less sensitive, or turn it off completely. And it really depends on the vehicle and on the system. The steering wheel thing comes into play is what they've done with a lot of these newer vehicles, especially with the ones that have the lane keep assist. The steering wheel is going to incorporate a capacitive sensor. So it notices if you're not touching it for a period of time, and it starts giving you warnings, whether it's visual, audio, or both. And if you don't respond, essentially the system turns off. And that's one of the things you've heard with, like, we'll use Tesla as an example. Tesla's had some issues where, people are on autopilot and they're in the back seat watching a movie. But what they did is they hung like a magnet device on the steering wheel. So it sees contact and it says, okay, there's somebody there. That may not be the greatest of ideas. They may need to add some more things to it. But the take the rest starts to come into play, and it's another system that we'll talk about on another day. The driver drowsiness detection. They're using cameras in some cars that physically look at the driver, look at your eyes and see what your reactions are. And the ones that aren't using physical cameras are actually looking at steering wheel input. If they see a change in the way the steering wheel input is, if you're on a long flat drive and you're wiggling the steering wheel, you're probably awake. If you're not touching or moving it at all, you're probably not awake, and you start getting the, hey, you need a cup of coffee warning and stuff. Mike Shermer mentioned someone could do an alignment and then the system could throw a fault. Exactly. And that's a big piece. When you look at the factory materials, they basically tell you, if you do an alignment, you need to calibrate the cameras and the sensors. It doesn't say if you do an alignment and don't change thrust, then you don't have to do that. They don't give you that exception. I have not seen that yet on multiple systems that I've tried to look up. So if you do an alignment, you're doing calibrations. If you do a windshield, you're doing a calibration on the glass, on the camera. So the mindset of, well, if I didn't change the thrust, I don't have to calibrate, that's out the window. I got to sit in one of the Hunter classes, and they were saying the same thing. You do an alignment, you need to be doing this. And most of the shops that were there that night were not doing it. And the problem with that is that's a liability issue. We got to remember, all this ADAS stuff is going to have direct liability connections with it. So anything that we talk about in a class, it's really important that we convey to the students, this is not something you fudge. This is something you do by the book, using the factory materials as much as possible, as close as possible, so that the liability isn't an issue. So the shops that don't do it, and there's an accident and they tie it back, oh, you did an alignment on that car 3 weeks ago, that you might be opening up to something. And, you know, we're in California. The laws get read differently here. Josh had mentioned, Mike should have mentioned that, but on the Camry, we did a four-wheel alignment on it after Johnny had finished his repairs and confirmed that we were still a good thrust angle before we did the calibration. Good. That's that preliminary work. And that's a big piece of it is, yeah, this preliminary stuff of having the vehicle in the right condition before we begin the calibrations. Richard, Toyota system needs to see steering angle sensor input at regular intervals. Yeah. So if it doesn't see you wiggling that steering wheel some, it starts thinking you fell asleep. Steve K, steering angle sensor, only one of 3 inputs where the car can understand what the driver wants. Steering angle sensor, very important. Yeah, brake, throttle, and steering is how the car has an idea what your intentions are. As we move more and more to autonomous, I would say it's what did you put into the navigation as a destination? That's how the car knows what you want as we get more and more towards that. John Taylor, if the vehicle is in specs for alignment check, what are the recommendations? If the vehicle is in specs for alignment check, what are the recommendations? I'm not sure what you mean by that, John. So if the first thing you would do if I needed to do, I had an ADAS problem, or even if I didn't have an ADAS problem, I had a car that came in, it had tire wear, I do an alignment, and now I need to go back and do those sensor calibrations. What are the recommendations, calibration? So if I had the car came in and it was already in spec and I made no adjustments and I have no faults, basically I would say I don't have to do anything. But if I had to make an adjustment, then I need to calibrate. I think that's the way I've read the manufacturer things is if you've making an adjustment, you calibrate. You know, if you've done, basically, if you've done that active alignment, you're doing a calibration. Mike Sherburne comment, don't go by red or green. Yeah, green is not good. And if you look, you know, everybody's seen a Hunter scale at some point in time, you can double click on that thing and it starts getting you down into the degrees of minutes, right? So, or minutes of angle. So, and specs are now in minutes of angle, not just degrees. So it's really tightened up. Mark had mentioned that the dealer, half of his calibrations were sublets from other shops. And yeah, especially at the independent level, this stuff, it's, you know, like EVs and hybrids were in the past. It's like airbags and programming has been. A lot of the independents don't want to touch it. They're going to send it to the dealership for those next steps. In some cases, though, you're actually seeing independent shops open up to do nothing but ADAS calibration. And the dealers are one of their customers sometimes because it's cost effective for them to have somebody else spend a couple hours trying to get it all squared away than for them to do it themselves. Body shops are also going to be a big player in all of this, to where, you know, if you got a body shop, if you have enough volume, can you justify the floor space to have a dedicated stall to do the calibrations all day long? Or do you find that shop that you sublet to? And there are shops out there that are doing just that right now. They've specialized in ADAS calibration and they're making a living doing it. Steve K, exactly. We need to align by the numbers, not the colors. Yeah, can't say that one enough. Align by the numbers. Let me go down here. I'm not sure what happened with Dan there. So if any other questions come up, go ahead and throw them in there and we'll move on to the next thing. There we go. All right, parking assist. Now, parking assist is a system that's starting to see a lot of evolution. It's getting closer and closer to autonomous quite rapidly. We've seen these systems go from very minimal control. So the earliest systems, if you wanted to have park assist, you would get it into that mode and it would control the steering and you would control the brake and the throttle. And then they evolved to where it controlled the steering and the brake, but you controlled the throttle. Most of the current systems, you push the button or hold the button and it does everything for you at that point. The systems have gone from just a parallel parking to being able to do an angle in parking or even a back in parking or reverse into a parking space. So the angle and the direction are not an issue for the newer systems. A lot of different names, parking assistance, parking assist. As we get into some of these other versions I'll show you in some videos, you'll see some even newer names to that. But again, let's see what Toyota does.
The Intelligent Parking Assist System, or IPA, is designed to help support the driver during parking maneuvers under certain conditions. The system measures potential parking spaces and automatically operates the steering wheel to help support the driver during these parking situations. IPA also utilizes the Intelligent Clearance Sonar, or ICS, to help the driver mitigate and, in certain cases, prevent collisions when parking. In certain conditions, ICS uses sensors on the front and rear bumpers and may detect potential collisions or objects in the direction of travel. When active, the system reduces acceleration or applies the brakes to avoid or lessen the impact in certain situations. IPA functions when the vehicle is in the Ready On mode and traveling less than 19 miles per hour. When activated, IPA uses ICS to measure your desired parking space and confirms clearance of vehicles adjacent to the selected parking space. At certain times when using Intelligent Parking Assist, the vehicle will automatically control the steering wheel. But the driver is always responsible for stopping and controlling the speed of the vehicle. Be aware of your vehicle's surroundings and always follow the instructions in the MID. The MID contains several key instructions. The advice display instructs the driver to shift between drive and reverse and instructs when to stop or park the vehicle. The countdown bar indicates that the vehicle is getting closer to an object and that the driver is approaching a full stopping point. The stop sign icon appears when the vehicle instructs the driver to stop. The vehicle icon alerts the driver to the vehicle's proximity to objects detected in the direction of travel. And the steering wheel icon appears while the vehicle is automatically operating the steering wheel. To parallel park, pull up parallel to the vehicle behind your desired parking spot and press the Intelligent Parking Assist button once. The Parallel Parking Assist screen will appear in the MID. Always check your surroundings, and while steering the vehicle, slowly pull forward to allow the system to measure the available parking space. When the system finds a suitably sized parking space, a beep will sound and a message will appear in the MID alerting you to stop the vehicle. Following the MID instructions, shift the vehicle into reverse. The reverse warning buzzer will sound. Another beep will sound, notifying you that the automatic steering assist control is engaged. Please note, the driver is responsible for stopping and controlling the speed of the vehicle using the brake pedal anytime the automatic steering assist control is functioning. When the beep sounds and the stop icon and message appear in the MID, bring the vehicle to a stop. If the system instructs you to shift into drive, shift and use the brake pedal to control the vehicle's speed and slowly move forward. Stop the vehicle when the beep sounds and the stop icon and message appear. Shift the vehicle into park. In certain conditions, Intelligent Parking Assist may also help you exit a parallel parking spot. To activate the system, be sure your vehicle is in the Ready On mode and in park. Then, press the Parking Assist button once. In the MID, the Exit Parallel Parking screen will appear and provide instructions. To begin, use your turn signal to notify oncoming traffic and let the system know whether you'd like to depart left or right. With your foot on the brake, the system will instruct you to shift the vehicle into reverse or drive, depending on your vehicle's distance to other vehicles and the amount of clearance available in the departure path. A beep will sound and the automatic steering assist control will begin. While following the MID instructions, use the brake pedal to control the vehicle's speed or stop when necessary. As you exit the parking spot, watch for oncoming traffic. When the system is finished, a beep will sound, and you must take control of the steering wheel from this point and continue on your way. Another helpful parking assist mode is back-in parking. To back into a parking space, you must stop the vehicle in front of your desired parking spot. To back-in park, press the Intelligent Parking Assist button twice. The back-in parking assist screen will appear in the MID. check your surroundings, and while following the MID instructions, slowly pull forward and steer the vehicle as needed. When the first beep occurs, parking assist and automatic steering wheel control will begin immediately after the alert. When the beep sounds and the stop icon and message appear in the MID, stop the vehicle and shift into reverse. While backing up, you must control the vehicle speed using the brake pedal. Another beep will sound, and the stop icon and message will appear, alerting you to stop the vehicle. When the MID advises that back-in parking assist mode is complete, shift the vehicle to park.
So I know that was kind of
Full-speed dynamic radar cruise control supplements can.
I know that was kind of a long video, but I like to have that one because it shows all the different parking ways that that system's capable of. Again, the original systems were only going to give you a parallel park, and depending on the vehicle and depending on the system, it might not do much more than the steering, and you would be doing the brake and the throttle. With the Toyota one that we were just seeing, it was doing the steering and the throttle, but you were still doing the brake oftentimes. Some of these systems will actually require the driver to push and hold a button through the whole process, kind of as a dead man switch. If they let go of the button, the system stops, puts it in park instantly. One of the things that come up and through all this is, how do I start to bring this into my classes? You know, I don't have time, or I don't have space or whatever to have a big standalone class. This system's a good example of, if I was teaching a steering class, I could bring this system into a steering class because it gives me an instant point of discussion. How is the car steering by itself? So if I haven't talked about electric steering yet, this all of a sudden becomes a great introduction to electric steering. Well, how's it doing that? Well, it uses electric steering, and now we bring that in that way. And that's one of the ways that you can start to integrate this into an existing class, is by saying, hey, this system uses electric steering. Here's the introduction to electric steering. Here's how it works. Or regenerative braking in a brakes class. Here's how regenerative braking works when you're talking about a hybrid or an EV. So you can utilize these in very strategic places. And that video in 5 minutes starts to bring up that, hey, how does it do this? Or the lane keep stuff. That's another one where active steering or electric steering that's got to come into play. So there's ways to integrate this into existing classes that aren't going to take days and weeks and months. It works as a good introduction point. Or even after the fact, hey, you've talked about electric steering, asking the students, what would be applications for electric steering? Hey, the park assist, the lane keep assist, semi-autonomous, autonomous driving, things like that. So these start to come into play for a lot of different areas. So what's parking assist? It's a system that assists drivers with vehicle parking. They don't even make them parallel park to get their driver's license anymore, from what I understand. So this is a really important system for new drivers. There are varying levels of it. Again, some of them were pretty rude and crude and did very little, and the driver had to do a lot more, and a lot of the newer ones do almost everything for you. Earlier systems, they were very slow in performing the maneuvers. The newer systems, some of the cars, they can go pretty quick. They're a little scary. How much it's going to hit or what it's going to hit as it's going through its activation. The paralleled and the angled, believe it or not, the angled and the straight parking are newer. Everything was originally just the parallel. And we're also seeing self-parking on some of these newer systems. What's it going to do for us? Well, hopefully it helps people park in one parking space and not three, but improves passenger safety and things like that. And again, we're utilizing primarily with these systems ultrasonic sensors, but different cars, you might be having cameras in play, you might have radar in play. This is going to be an active, not so much a passive system. So that's really that fundamental park assist. But we've all seen the TV commercials, so let's see what some of these next applications are. So this next one is a Hyundai system.
The available Remote Smart Parking Assist, or RSPA, is a great feature that helps drivers park their vehicle in tight locations, like a full parking garage. It allows the driver to move the vehicle forward and backward while remaining outside the vehicle using the smart key to control it. RSPA performs a function called Remote Moving Forward and Backward. You can stand outside the vehicle and move it, but you must be within 13 feet of your vehicle. First, pull your vehicle in front of the space you wish to park in. Then, place the vehicle in park, and then press the RSPA button on the center console. Instructions on the LCD display will inform you to use the proximity key, also referred to as the smart key, to move the vehicle forward and backward once you exit the vehicle. Upon exiting the vehicle, stand in a safe position within 13 feet of your vehicle. Then, take the smart key and hold either the move forward or backward button. The vehicle will travel up to 23 feet while holding the button. Pressing and holding it a second time will allow the vehicle to travel up to another 23 feet. Remote moving forward and backward will stop if it detects an object in the way. It can also turn the steering wheel to avoid detected obstacles. To cancel remote moving forward and backward, release the forward or backward button. Then, press the remote start button on the smart key. The vehicle will go into park, engage the parking brake, and switch off. Or you can enter the vehicle with the smart key and depress the brake or close all the doors. Then the ignition will stay on. You can also activate RSPA from outside the vehicle without pressing the RSPA button. Press lock on your smart key. Press the remote start button. The vehicle lights will flash and the engine will start. Once this has occurred, press and then hold either the move forward or backward button to have your vehicle exit the space. RSPA functions only under very specific conditions. Please see your owner's manual to review them and for more information on the system.
So that's kind of that next step, that the system, you can get out of the car. So those of us who have gotten shorter and wider over the years may not be able to get into that tight little parking space. I can get out of the car, push the button, have the car pull in, have the car pull out. And this isn't, believe it or not, all that new. They've been in some of the vehicles for about 5 or 6 years now with different manufacturers. But, that's that next step. But there's another step. As we continue to move closer and closer to our autonomous vehicles, I don't think that thing's going to go park in a parking garage by itself or come back to you. I don't know what the distance is, but it just gives you an idea that, these systems, they're all working together. The cameras, the radar, the steering, the brake, the throttle. And hey, if I'm pushing the button, I'm holding the button, I'm watching my car drive up to me. And do we need a parking valet anymore? But again, it's still those different layers that we continue to add. So all of these different things that come into play. And I just saw Ruben's chat. It appears the guy's going the wrong way. Yeah, you're right. I was thinking the same thing. It's a perfect video to put out there publicly. So parking assist operation. The idea is park the vehicle with little to no driver interaction, whether it's a parallel parking, an angle parking, or a straight parking. And some of the new systems can park via remote control. We're going to use ultrasonic sensors, radar, and cameras, depending on it. They're going to measure the space. So let's take that parallel parking scenario. When you pull up and you decide, hey, I want to parallel park on this stretch of road, you actually have to activate the system. And then you will drive past that parking space. And while you're driving past that parking space, typically what it's using is an ultrasonic sensor that's on the side of the vehicle, usually on the wheel well openings, and it's projecting outwards. And as you drive completely past that space, it measures that space. Once it confirms that that space is big enough, then it will give you notifications that say, hey, life is good. go ahead and do this. And now you're putting the car in reverse and pushing and holding the button depending on the system. And then it goes about its parking process. So it's going to measure. And I had seen one chime in there real quick, Mike Hernandez. Some systems need to detect two vehicles to do it. And that's true because that's how it's measuring that space. So if it's not measuring that space, it can't decide whether it can park there or not. It actually needs the two objects for it to base it upon. Again, it's directing the driver for a preconditioning in most cases. So that driver is going to be told, put the car in reverse or put the car in drive or step on the gas or brake or whatever. Oftentimes, the steering is the main control point of it. How are they going to know? It's going to give indications. It's typically going to give you chimes and indicator warnings, short text displays, things like that. But there's some things to keep in mind. Curb or no curb can come into play. One of the challenges for these systems is sometimes they can get very close to the curb. And in some systems, they've actually get their calibrations off a little bit and they'll scrape the rims on the curbs because they may or may not pick up the curb correctly. So curb height can come into play. What if there's a fire hydrant there or a tree sticking out a little bit? So there's some curbside obstructions that could be an issue. What if there isn't a curb? So you see some of these parking lots now where they've got parallel parking in spaces that doesn't necessarily have a curb. It may have an opening on the other side of it or a wall or something like that. Some of those may be confusing scenarios for the systems and it may not work right. Again, it's one of those, the driver better pay attention, not just push the button, because the car could impact something if it's not aware or doesn't fully understand how to deal with that particular parking scenario. So they're not perfect, but that's why there's a driver still. Components themselves, these systems are primarily ultrasonic sensors. Whether they're in the back bumpers, the front bumpers, you're going to have them on the sides as well. You've got all the applicable modules, control switches. It's going to interact with steering, brake, throttle. I haven't seen one that automatically shifts forward and reverse for you, but that doesn't mean it doesn't exist. There's, we've got drive-by-wire transmissions. There's no reason why it couldn't. I just haven't interacted with one that doesn't require the driver to do the park or the drive or the reverse and drive shifts. Visual indications, audio indications, all of those kind of things are coming into play. But the same issues that we had with our parking assist sensors previously are still issues. If I've got bumper damage, if I've painted over them, if I've clear wrapped over them, those will all be issues. What if I've got a bike rack on the back? What if I've got a trailer? Obviously, hopefully they're not parallel parking with a trailer, but they might try to parallel park with a bike rack. And it may not work correctly with obstructions. So those could come into play. And those would be good key points for if the customer came in with a complaint that, hey, my car won't parallel park, and you see a trailer hitch, you might ask that next question. Were you using the trailer hitch for anything? Did they have a storage rack on there or a bicycle rack or something like that back there that may come into play? And this was also one of the systems that I saw within Toyota that could be disabled via coding because, again, with the SUVs and the trucks, they were assuming people might be towing or have things in the trailer hitch like bike racks and such to where, hey, they want to have that system be off so that it doesn't give them false positives in the reverse mode. Okay. Go ahead, Mark.
So the band for some of this radar is pretty narrow, right? There's not a whole lot of frequency in there.
Yeah, especially up close.
So I'm just wondering how susceptible, as more and more cars get this, is there going to be interference between waves and frequencies? Sorry.
I think the big thing is going to be most of these systems are only active while they're in use. So let's say on that ultrasonic sensor, the only time they're on is when I put in a reverse and then maybe when I first go into drive and start moving, and then the systems go back to a standby. When we're talking the radar, same kind of thing on the reverse, those side radars might only be active while I'm reversing or if I'm driving down the road above a speed. they shouldn't be bouncing off each other too much unless you're just, stop and go traffic could be an issue where they were bouncing off of each other. But I want to believe that that's something the manufacturers have looked at and dealt with, making the assumption, hey, a car's going to sit and stop and go traffic. These sensors could be banging on each other all day long. Is that going to be an issue? And I haven't heard of it being an issue. So I think it's one of those maybes, but I haven't heard anything or heard of problems with them. A lot of these things we've had for quite some time in various vehicles, and they haven't really come up and said that they've had issues. So I think we're a little safer than we think with it, but it's definitely something that could be an issue, maybe down the road or something, or they come out with a new series of radar or something like that that could interact with the other ones negatively. That's a possibility too. Okay. Let's see here. Where are we at here? Parking diagnosis, damage, fault codes, power grounds, and signals, guys. Calibration of these. Now, most of the time we're talking ultrasonic sensors when we're talking these park related things. So they're not calibrated. The most important thing with ultrasonic sensors is the sequence, making sure that when you plug the connectors back in, that the connectors are in the right sensor. If you put them in the wrong sensor, they lose their sequencing. They don't fire all of the ultrasonic sensors constantly at the same time. They go in a sequence, and that's how the system knows if the obstruction is on the left side of the vehicle or the right side of the vehicle, because they're pulsed. If you have the wires switched, it pulses the wrong sensor at the wrong time, and it might think it's going to give you the indication of an obstruction, let's say on the right rear of the car, that's really on the left rear if you had the harness completely flipped over. So the connection point is going to be a big thing. Okay. Now, with these park assist systems, even if you're not using the park assist, most of these cars, I think it was a 2016 or something like that off the top of my head, where cars were required to have backup cameras. And some of these systems, whether it's just a static camera, but a lot of the newer cars have these active assist to where they've got the targeting lines that help you back up and pull into a parking space more accurately. So when you have those rear cameras involved, there's another calibration involved for that rear camera. So this next video clip, it's Bisbarth, and they're one of the big European companies. There's no audio in this, that provide most of the OEM stuff for the European manufacturers. So what he's doing is he's laying out the targeting for the rear cameras. So since these vehicles may have those targeting grids or the parking assistance stuff, the moving lines, you've got to make sure that camera's calibrated correctly. So he's going to go through, you're going to see him do a plumb bob to find the center point of the wheel and then give it a mark on the ground. They'll do the same thing in the rear. And essentially what they're doing, this is those prerequisite things. So he should have already confirmed his alignment, confirmed his ride heights, and now he's basically confirming that the vehicle is going to be square to the target. Now he's going to go through and make sure that he's got the target at the right distance from, in this case, the center line of the axle. And then he's doing the same thing on the other side, because again, he needs that target to be at a 90 degree to the vehicle. And then putting down the applicable target squares. Now, some vehicles will do it this way. I've done them on a BMW where it had kind of a ladder assembly that came off the back of the vehicle, actually used hub-based clamps for like KDS alignment heads. And then you had like a ladder attachment that came out the back that you would calibrate a laser off the back of the vehicle and have that set at a certain spot, and then you'd lay a target on it, and then the camera would calibrate to a target. But the whole idea is making sure it's dead center behind the vehicle at the right distance so that the camera could then calibrate to that point so that all of those backup grid or those target lines would be in the right place at the right time.
I'm assuming they're using a Bosch system to calibrate that?
That one was Bisbarth. So there's a, you know, everybody makes one. Autel's got their own stuff. When I was doing BMW, it wasn't even a Bosch. It was a who knows who company that was making them for BMW.
I like how inexpensive that was too, because some, you know, when you have the boards that are thousands of dollars, you know, for a training program to have that, it's out of reach. So that was nice, that rollout target board.
Yeah, but I will give you a hint though, Bisbarth's expensive. So it may look like a cheap thing. It's going to be expensive too, because Bisbarth's pretty expensive stuff. They make everything, and most of it is the manufacturer factory equipment in some cases. But yeah, it's top dollar. So let's see what kind of
that Bosch system you showed us last time. Remember that?
Yeah. And I haven't seen the price point on that. I know Pam had sent one out. I think it's pretty competitive with what we're seeing from Snap-on and Autel. So it's in that 20 to 25,000 range, depending on how you set up, what targets and stuff you acquire for it.
Bosch is very competitive. It's around 15,000. They're really doing their best to match, because ADAS came down their pricing and Bosch matched it. So they want to work with us. Price is not going to be the obstacle.
Good. So let's get into some of the Q&A here. Paul had mentioned Toyota started using parking assist in 2010. Ed Woodworth had mentioned this type of equipment is going to make people really think hard about salvage titles if they know. And yeah, that's going to be a big issue. The one that Josh had spoke of earlier, the guy that had bought it is the collision instructor. And he had bought the car and did whatever repairs they needed to do, and then they needed to go back through and do the calibrations. I know another former instructor, a friend of his, had bought a BMW that happened to be fully loaded and bought it through auction. Come to find out, it had been a salvage car, and it had a lot of ADAS faults in it. So he tried to take it to the dealer to get it done. The dealer wouldn't touch it because it was a salvage car. Tried to take it to a few other shops, and either they just didn't do it or they would not do it. He finally found a shop that would do it for him after hours on a Saturday. And I think they said it took him 3 or 4 hours to go through and do all of the calibrations, and everything calibrated fine. They had no issues with anything, but the whole salvage and liability thing came into play even for some of the shops in their willingness to do it. So yeah, if you're looking at ADAS cars, that vehicle history becomes pretty important. Ruben had mentioned, what are the system names of the systems to park remotely? The Toyota one, the name just slipped me, park something, or park assist system or something like that. Again, different manufacturers, they're going to have different names. A lot of them were just simply park assist. Let's see here. Laura, many collision shops have implemented as part of their blueprint and standard operating procedures pre and post scans to pick up post collision and post repair codes, which takes care of ADAS systems. Some are using in-house diagnostics, sublet to dealerships, and or third-party remote scanning services when possible. And that's one thing I've heard in a couple of different places is there are a couple of companies now that it's a subscription service, and you plug in and basically they scan the car remotely and check for faults and make recommendations and stuff. So I've heard it mostly in the collision side where they may not have a technician for the repair, but they'll use that remote service to clear faults, post repairs, and if the repairs need to be done farther, then they make those recommendations and they send them out or whatever. But that's also, and it's a big company, it's a nationwide company, but the name slips me. Adrian, parking sensors or parking systems in JAG are neat. I haven't seen the JAG one. It's probably similar to most of the other ones. Ruben's answer got through there. Good. Mike Hernandez had mentioned some systems need to detect 2 vehicles before they'll park. And yeah, especially on the parallel parking, like I said before, they need to know a space. I guess the mindset is if there's not a car in the way, you should be able to park yourself. Ruben had mentioned, appears that Tesla's driving the wrong way. We'd mentioned that. Mark, could you imagine people leaving a baseball game while summoning their cars? Yeah, Michael had mentioned self-made demo derby. Well, it shouldn't be a demo derby because all the car sensors and cameras should keep them from crashing into each other. It should go perfectly well with absolutely no problems whatsoever. Yeah, I got a bridge for sale too. Edward with no baseball, no problem. Yeah, that keeps them from crashing. Does it detect other moving vehicles? If you're talking about the Tesla Summons one, my understanding is it does. So essentially it's using like its autopilot function in a sense that it should react to obstructions. Even that Hyundai one they had mentioned, if something was in the way, it would brake. The other thing is you're supposed to be in view of the vehicle and you're holding the remote button in most of these cases. I don't know if you're still, I think you're holding the remote the whole time on the Tesla too. But you know, you have some accountability with it as well. You should be holding the button, paying attention. The vehicle should still react, but you also should be there too. Mike Hernandez, Tesla does shift automatically, so that's good. When we were talking about oftentimes the driver is the one having to make the reverse and park or reverse and drive selections. Let's see here. Paul, if you're in rain or snowstorm, will this affect the radar cameras? Yes. Yes. Just because it's a parking assist situation, if you can't see, it can't see. So depending on how bad the rain, the snow, the sleet, the smog, the fog, the smoke, whatever, if there's an obstruction, it would deactivate that system. If the cameras couldn't see correctly, they would turn off and those systems shouldn't run. Laura had mentioned Aztec. Richard, Hyundai Smart Park, great Super Bowl. Yeah, the Smart Park. Yeah, that was a good ad. Mark, interior cameras are coming next. Interior cameras, we saw them in San Jose, and they've actually been in some cars for a little while, part of the driver drowsiness detection. So there are some cars that already have cameras in there looking at the driver's face, primarily for the drowsiness detection stuff. The stuff we saw in San Jose, about a year and a half ago, we're looking at a lot of other things as well. But that kind of covers all the bases for today. If everybody's got more questions, throw them in there, or you can go ahead and throw the mic live if you want. Next week, we've got another one before the break. We'll talk about intelligent high beam assist, front collision warning, and hill descent control, which is not real new, but it may be new to some people. But otherwise, thanks for being here. Thanks for listening again. Hopefully it fills in some blanks for you, provides you some information and some materials to use. Again, you can access all these videos and all the PowerPoints up on the ATL site. So if anybody's got any other stuff, I'll be watching in the thing. Otherwise, we'll see you next week.
Thank you very much. It was very enjoyable.
Thank you.
Thanks, Kurt.
Mm-hmm.
Thanks, Kurt. Thanks, Pam.
Thank you, Kurt.
Thanks, everybody.
Have a great weekend, everyone.
You too. Happy
Father's Day, everybody.
Day, everybody.
Happy Father's Day. Yes.
Hey,
Oh,
Pam,
yeah.
are we going to get recordings of these?
Yeah, they're on the website.
Oh,
So
okay.
go to the website. For each week, there's a separate page set up on the website so you can access the PowerPoints, the recordings, the chat, everything.
Yeah, so that same ATL page, you go to the faculty, go to curriculum, and there'll be a little line that will say new ADAS webinars. Click on that, and it'll have the video, the recorded video, and then right below the recorded video, it has the PowerPoints that I'm showing with all the slide notes.
And on Tuesday, when I sent out the email, I included the direct link to that in that email. about halfway down.
And then how about the session we had earlier at 11? Is that going to be also recorded on
Yes,
there?
that was recorded as well. And I'm going to send out the PowerPoint separately. So everybody has the PowerPoint that they can use internally for their own purposes for presentations or discussion points. But everything's going to be on the ATL website, both the recording as well as the PowerPoint.
Yeah, and those are in the webinar area. So if you go back to the main site, go to the faculty, and you'll see a tab there that says webinars. They're under there that they've been doing those community of practice ones in.
Thank you, Kurt and Pam.
No problem. Thanks for coming, Blair.
You're quite welcome.
Thank
Quite
you.
welcome. Hi, Mike. Did you score well in your game today?
My what?
Your golf game.
I didn't play golf. I'm in Sacramento visiting my mother-in-law.
Oh, that's a good excuse. Yes. We have to razz you a little bit, Mike. So actually,
Hey,
while I
Mike.
have the three of you on the phone, I see Mike, Dave, and Mark there. I got a text from Soren from Independence High School, and he was wondering whether or not there might be any interest in doing some kind of dual enrollment with his high school on ADAS. I said, I don't know. I'll have to check with you guys. I don't know. I know you guys are busy, but that's something to think about.
Well, I think what we need to do is, this is going to be incorporated into curriculum, right? But right now, we have some curriculum changes we need to do for online, and we're a little bit backed up. And that's one thing I want to discuss with Mike, because I was on a curriculum meeting earlier. So I don't know, Mike, would you have a few minutes after this to discuss that?
Sure.
Okay.
Okay.
And
Well, I passed
since
that
David's
one
on here too.
Yeah,
Yep.
Dave's-
What's that, Pam?
Yeah, we're ready to do those supplemental things.
Cool. Okay, great. Well, thank
Thanks,
you.
Kurt.
Great.
No problem, Mike.
Thank you. Good show.
Thank you so much. You
Thanks,
guys
Dave.
have a great weekend. Happy Father's
You
Day.
too.
Okay. You too.
Take
See you
care.
later, everybody.
Thanks, Kurt.
Oh, there's Ron and Ed still on. Oh, Sherman's on. There we go.
Did you have to readmit Ed?
Yeah, and I had a real problem with Dan Sillen.
Yeah, I saw him popping up a few times, and
About 20 times. He was
yeah,
doing something on his end, so I finally emailed him because I didn't want to remove him.
yeah.
Thought if there was an error in the program here, he might have to just be removed and then re-enter under another email address or something, because he was confusing the system and it kept trying to get him to be readmitted.
Yeah.
And
You know, one thing I just saw in here, we were doing the remove, and I think that may be screwing him up, is there's a put and wait room there. So I'm going to do that with Adrian, because he may be asleep or whatever. I'm just going to put him in the wait room. That way we can finish up.
yeah,
And then same thing with Michael,
yeah, I see Mitch and Sherman.
or Mitchell, excuse me,
Yeah.
and
Then
Sherman.
we have
And then,
Ron Palmer from College of Alameda, College of Marin.
yeah. So, yeah, I don't see Ron
I
on
see
in the participant list, though. It's kind of weird.
Yeah, why is he showing up?
Let's see if I can do it from his window. Yeah, I can do it from his window too. Okay. So it's just you and I in here now.
Okay. Yeah, there was some little errors going on like that, which keeping me busy, but it also distracted me. I did something terrible. I did not record at the beginning.
I think you had it on there for a little bit, and then it went off, and then it saw it kick on. So
It was
it's okay.
on, and then I must have clicked it off or done something, because then I realized it was about halfway through, I thought, why is that not recording? In fact, now it is recording.